Hello everyone, this is Muhammad Fathi from another video from Analytical SQL. If you didn't watch the last videos, please check the playlist from below. What did we take before? We took an introduction about Analytical SQL and its advantage, a revision on Subquery and group by, and at the end we took a CTE and what is it, what is the difference between Subquery and CTE, and we took applications or examples on both of them. Now we will take a very important and very interesting topic, which is window function, which is actually the first topic or first important topic in analytical SQL. What did we take before is to prepare us for what is coming now. So let's go. Let's go. Okay. What we'll take today, an introduction about window function, the difference between window function and basic SQL and the clauses of the window function, and also some examples on window function. What is window function? The window function in an easy way is something like aggregate function and group by, but without collapsing the data. So you can make any aggregation, any calculation on the data and put it beside the row. But not just that, but it also gave us an advantage on calculating few things in an easy way. Like what? Like ranking the employees, like getting the previous revenue, for example, and so on. We will see everything today. Okay, let's compare between the aggregate function and window functions. Of course, the easy part that the aggregate function collapses the data, but window function doesn't collapse the data, and that's the first difference. The aggregate function collapse if you have 3 rows, 4 rows, 5 rows, it will collapse it into one row. But in window function, it puts the calculation in each row. So it doesn't collapse the data. If you want to calculate the average salary per department, for the aggregate function, it will collapse it and will put just the department and beside it the average salary. And you can't view the data of the customer in the same row in an easy way. But in window function, you can select the customer name and select his department, and beside it select the average salary in easy way because it doesn't collapse the data. You give it a window, it sees from this window the data that is allowed to use in the calculation, and then it does the calculation direct. So, in a comparison between the aggregate function and window function, what is the purpose of aggregate function? The purpose of aggregate function is to collapse the data and summarize it and give you an output. But the window function, no, it's the best way or best practice to view the data beside a row. What if I want to collapse the data with window function like aggregate function? You can use distinct. So distinct here will remove the duplicates, so it will do the same function of aggregate function if you didn't select any other row you don't want to compress. So group by is required for aggregate function, yes, but in window function, no, it's not required, but you can use it for another purpose. Does aggregate function collapse the data? Yes, but window function, it doesn't collapse the data. Example of aggregate function like sum, average, count, but in window function, there is even more. Sum, average, count, and also there is rank, didn't rank, there is lag or lead, there is last value, first value, and a lot of functions. We will take it today, or we will know about it today. Use cases, for example, total revenue per region. For window function, you can calculate the running total, and we will take an example on running total today. So let's go. So what is the functions in window function? It's distributed. This is the most common window function that we can use, but they are not all. We have aggregate functions like count, sum, average, max, and minimum. Ranking function like row number, rank, didn't rank, entire, and percent rank. And value functions like lead, first value, last value, ninth value. And we will take them all in details later. Today we will focus on what? We will focus on aggregate function. Okay. Let's have an easy business scenario. An HR want to determine the sequence of hiring for each employee. So if this employee is hired, I want to know his order of hiring. If I have a company, the first one hired will be number 1. The second one hired would be number 2, and so on. Can we get this without analytical SQL? This is the required output. Can you pause the video for a minute and think about it without analytical SQL, how to get it? If it's easy, write it easy in the comments. If it's not, tell me if that it's not easy. And the analytical SQL is much easier. So, we will put the both solution in front of each other. For the subquery, we will select employee ID, salary, and hire date. Okay? And beside it, we want to select the hire sequence. How can we do that? Let's imagine that the first one hired in the company didn't have anyone hired before him, so we will count how many employees before him beside him. So he will be 0 employees hired before plus 1 plus him. Okay, for the second employee hired, how many employees hired for him? Just 1 plus himself, then 2, then his hire sequence is 2, and so on. It needs a lot of critical thinking to get the idea or to make the workaround to calculate it. Also, you will need to make a subquery in the select to count all the employees where hire date is smaller than or equal to calculate himself of the first hire date. You need to make a related subquery to use the hire date of the outer table and the hire date of the inside table. Okay, so it's very complicated actually. And if you need to make order by, you will do it at the end. Let's see another part. In analytical SQL, it will tell you no. Actually, you have a function that make the order for you. You just need to use it. Need to tell it what column will order by to count in order. You need to tell it if it's ascending or descending, and it will do all the job for you. So all this critical thinking, all this logic, it's replaced by only one line in analytical SQL. So what is easier? And here is a very important topic actually, the execution sequence. Why we need to understand the execution sequence? Imagine that the analytical function happens in some time. Can we use it before this time? No. So, for example, the from and join is executed before the analytical function. Can you use analytical function in them? No, because it's not yet executed. Analytical function happens after the where condition, and that's a very important part, please focus. Does the analytical function can be used before or inside the where? No. Because this mistake, if you use ChatGPT analytical SQL, it will always fall in it. If you calculate or too many people who use this analytical SQL also get an error because using analytical function in a step, it's not yet executed, so you can't use it. So the execution sequence is much more important than writing the query. First, we have the from and join, then the where, then the group by, then the having, and those are not allowed to use any analytical function in them. Then number 5 would be the analytical function. You can use then the analytical function, the select, distinct, union, order by, and limit. Because why? Because they are executed after the analytical function. And now let's know the clauses of the window function. Let's go. First, the over clause. What is over clause? Actually, when you make any aggregation, sum, average, row number, rank, there is an over clause where it tell you what will you use to make the calculation. So if you make sum and open two brackets and close them, then you write over and open two brackets. If you didn't put anything in the over clause, it will calculate all the data because you gave it all the window. But if we want to give it a small window, for example, make this average salary for each department. So you give it a clause of partition by inside the over clause. Partition by is something like the group by, but without collapsing. If you want to tell it order by something, order by date to calculate the number or rank, order by sales to calculate the summation cumulative, like the first day will be 100, second day will be today's sales and the last sales. If you want to make it for all the company or all the department or all something else, so you can use the over. And this is the partition by. Partition by is used inside the over, inside the two brackets of the over, to tell the over, please tell the summation function or any function to calculate for each partition by field. So if department, it will summation for each department alone. And now the order by. The order by is used to order data. For example, to calculate the cumulative sales, for example, or to calculate for you the rank or the row number or the order or anything, you need to tell it what column it will order by. So if you will calculate the total sales, for example, don't use order by because it will calculate it cumulatively. So what does the over contain? It contains partition by, order by, and now the most important by the over clause contain, which is rows and range. It's very important actually, please focus. The rows and range is a game changing. You don't only tell the analytical function to make the summation for some fields, no. For some departments, no. You can also give it a range of time or a range of value or a range of rows. Tell it to calculate this and 5 rows before. Calculate this and 5 rows from this department. You can use partition by also. Calculate this for last 30 days or last 5 months or last 100 seconds. You can make a window of calculation for a specific range of time or fields. Calculate the average salary for the current salary plus or minus 10,000. You can do this also. So the rows and range is a game changing and we will have a lot of practice about it. And this is the syntax. You write the function, over, open two brackets, put the partition by, put the order by, put the rows or range, close. Okay, the over clause is used with partition by and order by. Partition by instead of group by, as we said, order by to make the cumulative. And now let's see some real example. For example, here, it's the same example actually that we took before or something like it. We will rank the people in the department by, in each department alone, by their salary. So the highest salary will take number 1, the second highest salary will take number 2, and so on. Here, for example, for department number 10, it's only one employee, takes the salary of whatever, so his rank is 1 and no other rank. Here we started another department, so we will start another rank because it partitioned by department ID. Okay, and this employee takes the highest salary in the company, so it takes number 1. And this employee takes the second highest salary in this department, so it takes number 2. Here is a new department, so it will make another calculation from the start. Let's take a business example actually. A company wants to track the bonus of their employees and want to see each employee what is the points awarded for him or what is the total bonus. So we can calculate it easy actually with sum and group by. Sum, points awarded, group by, employee ID, and it will be so easy. But let's try it with the window function. We will put this thing to overcome the duplicates because we have 6 rows, it will have 6 output and we need only 2, 1 for each employee. So we'll use this thing. Distinct employee ID and sum. Inside the sum, you give it the column that it will sum. Logic. But in the over condition, you will tell it to partition by employee ID. Calculate this sum for each employee as total points from employee points. And here you get the employee ID. In front of it, the total points this employee ID got. And also for 202, 201, and so on. For all the employees. Let's take another business example, which is a game-changing and very important. We have here two concepts used in analytical function. It's very good actually. First, the cumulative total revenue, and we call it in other word in the business, the running total. Why? Because we, as if the revenue is running and accumulated one by one or row by row or day by day. And also, it's mentioned here that we want if the transaction type is refund, don't put it in the calculation. Oh, in the analytical function, we don't use where or having. How can we exclude some values from calculating another value? We not calculate the amount, but if the transaction type is refund, don't use it. How can we do this? Here, for the surprise, you can use case when inside the summation. So, summation open to bracket, you can use inside the case when. Case when the transaction type equals sale, then calculate the amount. Else, put 0, don't calculate. Over, partition by, calculated for each product, order by sale ID to make it running, accumulated one by one. Here we can put date. If we have date, we can put anything we want. If we put sales, it will not make it in order, good order, so we need to put it sale ID for the sequence of the sale itself. Here, the sale ID number 1, quote amount 500, sorry, so the running total is 500. This is 300, so it will be accumulated for the 500, so 800. Negative 200 plus 800. Oh no, the transaction type is refund, so it will not be calculated and it will stay 800. Here is another product ID, so it will start over amount 700, stay 700, this refund, so stay 700, and this is not refund, so it will be added at 900. And now we finished our video today, waiting you for another video. If you didn't watch the last playlist, watch it, subscribe and follow for more videos. See you later.